Hi guys, this is lecture 6.5, Resolution of Vectors into Rectangular Components. In the past few lectures, we have been talking about how when we have a number of vectors, we can add them or subtract them to create a different vector. In today's lecture, we're going to go through how we can have one certain vector with a magnitude and direction, and we can resolve it into two perpendicular vectors, one being the horizontal and one being the vertical. These are called the rectangular vector components of the force. So for example, if we have the vector v, which is shown here, that has an angle of A to the horizon, we can easily divide this one vector up into two vectors, which will be their components. We call it VH and VV. H for horizontal and V for vertical. Therefore, V, the vector V, will be equal to the vector VH plus VV. Now let's take a look at example 1 from your learning resources. A box weighing 140 newtons is resting on a ramp that is inclined at an angle of 20 degrees. Resolve the weight into rectangular vector components that keeps the box at rest. In order to do this question first, before we have to draw the diagram, we have to find out how many forces there are acting on a certain box. First, we have a force N, the natural force, which is perpendicular to the ramp, and then we have the friction, which is represented by little f, that is going to be parallel to the surface of the ramp. Then of course, every object on Earth have the force of gravity. But in this case, we don't know the mass, but we do know the force of gravity already, that's 140 newtons. So we do not have to time this by 9.8. And now we can draw a graph. Supposedly this will be the ramp that's 20 degrees to the horizon. And we have an object, the red box here, that's weighing 140 newtons. That will also be the force of gravity. We have the normal force and also the force of friction. Normal force is perpendicular to the ramp and the force of friction is parallel to the ramp. Therefore, the normal force will be perpendicular to the force of friction. Or we can draw it like this, vector addition. We know that the box is in equilibrium because it is not moving. Therefore, we know that when these three forces are added together, we will have a resultant vector of 0. And that will look something like this. This line, being the force of gravity, is 140 newtons. This line is the friction, in which we don't know what it is yet, and it's what we're trying to find out. As well as this line, we don't know what it is yet. This is the normal force. And the next thing we have to do is figure out the angle. We know that the force of friction is 20 degrees to the horizon, which means this angle right here will be 70 degrees. Now you can either work with the 70 degrees since this is the right angle triangle and just find the friction and the normal force very easily, but to be consistent with the book, with your learning resources, we shall use this angle. This angle will be 20 because this is 70 and this is 90, so this would be 20. So to be consistent with that, we have the magnitude of n is equal to 140 times cosine 20, which is equal to 131.6. The magnitude of friction will be equal to 140 sine 20, which will be equal to 47.9, and these two will all be newtons. The box is kept at rest by a force of 131.6 newtons, perpendicular to the surface of the ramp, and by friction of 47.9 newton parallel to the surface of the ramp. And that's the end of this lecture. Thank you guys for watching. Remember to do your assignment as well as upload them for your teacher to mark, and I'll see you guys next time.